Have you ever wondered why your production process is not as efficient as it could be? Now, take a moment to imagine the flow of traffic on a busy highway. When there's a lane closure, cars start to pile up, right? Similarly, in a manufacturing process, bottlenecks occur when input comes in faster than the system can handle it, slowing down the overall process. This is where bottleneck analysis enters the picture. Bottleneck analysis is a method of identifying the slowest part of a production process, which limits its overall capacity. Think of it as finding that pesky lane closure on your highway and figuring out how to get traffic flowing smoothly again. Why is this essential in manufacturing? Well, bottlenecks can significantly reduce efficiency and productivity, leading to increased costs and reduced profits. So, identifying and managing these bottlenecks properly can help optimize the production process, ensuring that resources are used effectively. Understanding your bottlenecks could be the key to unlocking higher productivity and efficiency. So, let's delve deeper and unlock this potential together in the next scenes. But where exactly do we apply this analysis and what challenges might we face? Bottleneck analysis finds its utility in a variety of sectors. From manufacturing, where it streamlines workflow by identifying process lags, to healthcare, where it optimizes patient flow in emergency departments. It's even used in traffic management, helping to alleviate congestion on busy roads. However, the path to pinpointing these productivity hampers isn't always smooth. One of the major challenges is data collection. Accurate, real-time data is vital to identifying bottlenecks, and gathering such data can be a daunting task. Another challenge is the identification of false bottlenecks. These are perceived slowdowns that, upon closer inspection, aren't the real cause of the delay. Distinguishing these from true bottlenecks requires a keen eye and thorough analysis. As with any analytical tool, it's not without its challenges, but the rewards can be substantial. You might be thinking, how do we perform this analysis, and are there better ways to do it? The conventional method of bottleneck analysis involves a manual process of identifying areas of delay or obstruction in your production line. This can be a time-consuming and error-prone process, often requiring repeated observations and adjustments. For instance, in the automobile industry, identifying a bottleneck could mean hours of tracking individual car parts through the assembly line. Now imagine a method that not only reduces this time and effort, but also provides accurate real-time data. Enter the world of manufacturing simulation. This technology allows us to create a virtual model of your production line. With this model, we can simulate different scenarios, identify potential bottlenecks, and test solutions without disrupting actual production. Take, for example, a pharmaceutical company. By using manufacturing simulation, they were able to identify a bottleneck in their packaging process. The simulation revealed that the packaging machine was unable to keep pace with the production line, causing a pile-up of products. With this insight, the company could focus their improvement efforts on this machine, thus boosting their overall productivity. In contrast to the conventional method, manufacturing simulation provides a clear, bird's-eye view of your entire operation. It's like playing a video game where you can manipulate variables, test strategies, and see the potential outcome before implementing it in reality. With the aid of technology, we can now identify bottlenecks faster and more accurately. So, what have we learned today, and how can we apply it to improve our processes? Bottleneck analysis, as we've explored, is a crucial tool in the world of manufacturing. It helps us identify where our process is slowing down, what's causing the hold-up, and how we can streamline operations for optimal efficiency. The applications are vast, from production lines to service industries. And while challenges do exist, like accurately identifying bottlenecks or implementing changes, the rewards are well worth the effort. Now, let's address those 5 questions we posed throughout the video. First, yes, bottleneck analysis can indeed be applied to any process, not just manufacturing. Second, while it may seem counterintuitive, speeding up the slowest part of your process won't necessarily solve your bottleneck issue. Third, the most common method of bottleneck analysis is the theory of constraints. Fourth, manufacturing simulation tools can significantly improve your bottleneck analysis by providing a visual representation of your process. And finally, yes, manufacturing simulation does indeed offer advantages over conventional methods, such as real-time analysis, and the ability to test different scenarios without disrupting your actual process. Looking ahead, our next video will delve into line balancing and how manufacturing simulation can support this process. We'd love to hear your thoughts or questions on this topic. Please comment below and let's keep the conversation going. Remember, the path to efficiency lies in identifying and managing your bottlenecks. Until next time, continue striving for better processes.